X or something, I'm not sure. So classification, scalene, all side lengths are different. Isosceles, two sides the same length, and equilateral, all three sides the same length. Okay. So in order to classify a triangle, is it sufficient just to get one length? Is it sufficient just to even get two lengths? No, because they could be both different. We still need to know something about the third. They both be the same. The third one can still be the same. So what we're really doing is just applying the length formula 3 times, right? So this is what I mean. This could be a valid test question. Is it difficult in concept? No. 3 length formulas. Is it a lot of work? Yeah. Right? So that's where you need to start get yourself going. Start moving, right? It's not going to be like the trigonometry test where you can kind of think about it, actually get done really early, right? There's a lot of work involved in some of these questions. So you need to move at a fast pace. So what I like to do is I like to draw triangles. So here we got -3, -1. So there's A. B is 1 and -3. Down here. And C is 3, 1. So if we connect the points, that's what a triangle looks like. Yes? Got a question?
No, I have some.
Well, I'm going to tell you that the length of AB, if you work all that out, comes out to be a square root of 20, which is the same as 2 root 5, right? Which is the same as 4 times 5, so square root of 4 leaves me as 2. Want to simplify radicals. The length of BC is also a square root of 20. And the length of AC is the square root of 40, or same as 2 root 10. Okay? I don't have time to go through, but it's just going through, plugging in that formula 3 times. Now the difficulty is, and I purposely put the points like this, is those negative signs. Those negative signs are going to trip us up. We're doing this part, x2 minus x1. We do minus and negative, we got to remember we're adding, right? So we need to be really careful with this. Because if you trip that up, you got the main question wrong. Whether, in this case, it's an isosceles triangle. But this answer isn't sufficient. What hopefully you recognize is that this is also a right angle triangle. So how do we actually determine whether a triangle is a right triangle or not? What does a right triangle mean? Yeah, there's a 90-degree angle in there. So there's 2 ways to actually solve this way. You could give me at least one. One way that you can show whether there's a 90-degree angle there or not. Well, finding the height doesn't tell us. So height is just another length. Fortunately, it doesn't tell us anything. Tells us the height. But how is that going to tell us if it's a right angle triangle? What do we know about 90-degree angles? About the slopes. What do we know about the slopes of 90-degree angles? What about the slopes of those lines? What is it that we know about them? The lines are perpendicular, yes. What do we know about the slopes? two words. Thank you. Negative reciprocal, right? So in other words, we have to do some slope calculation here. One thing about drawing a diagram is if I'm looking for, I want you to tell me this is a right angle triangle or not, is which one looks like it's a 90-degree angle? A, B, or C? Okay. Yeah, so it looks like this one might be. So if I can prove that one is, then I'm done. So what I need to do is I need to calculate the slope of AB, which is delta y over delta x. So AB, I'm going to do delta y is 1 minus a negative 3 over negative 3 minus 1.
Where are you getting the numbers from?
I'm using the points.
So,
here,
oh, okay.
what points am I using? Delta y, I forgot a negative here. So negative 1 minus the negative 3, and then negative 3 minus 1. So that gives me a slope of negative 1 plus 3 is 2 over negative 4, which is negative a half. Okay, so that's the slope of AB.
Why'd you make it negative 1 in the equation?
Because the point here was negative 1.
Oh, I was thinking.
Okay, so I use this point A, so it's really A minus B.
Yeah.
Slope of BC, so delta y over delta x. So here BC is negative 3 minus, let's say, is that a 1? I lost my coordinate. Somebody help me out, is that a 1?
Yeah.
And then the delta x is 1 minus
3.
3, thank you. So I get negative 4 over negative 2, which is equal to 2. So are those negative reciprocals of one another? Right?
But
It
did
is.
we, to figure out how to classify the triangle, we didn't have to do that, did we?
No.
Because as long as you find, if you just find the length.
Part of the classification is telling you if it's a right angle triangle or not.
Oh, okay.
Okay?
So since they are negative reciprocals, we know for sure that B is a 90-degree angle.
Yes, exactly. So therefore, since MAB is negative reciprocal of MBC, ABC is a right angle triangle. Right angle isosceles triangle. Okay, you had a question, Fred? Just by looking at it, look, because that was the biggest one, it looks like it might be 90 degrees. What you could do is, you could do the third slope formula. So you could do the slope of AC, so basically instead of doing two slope formulas, you just do 3, and then you look for negative reciprocals amongst all 3 of them. And so you just see the one of them, right? But here, because I got in the first, I don't need to calculate the slope of the last one, because I already got my negative reciprocal. I already proved that this is a 90-degree angle. Yeah, if I did it and this wasn't a negative reciprocal, I would have to calculate the slope of AC and C. And if that wasn't negative reciprocal of anything, then it's not a right angle triangle. Then it's just a regular isosceles triangle. Since the slope of AB is the negative reciprocal of slope BC, then triangle ABC is a right angle isosceles triangle. Sorry?
Don't you agree that the only thing that smartboard is good for is having grids?
No, you know what? The one in Mr. Doma's room is way better.
It's just like better at like tracking.
It is. And actually, the one in 219 is better. This is off for
Well, you
some
can
reason.
record stuff on that.
So the nice thing is because I could capture the screen. on here.
It's so much
This
messier
way.
on the.
Pick up a camera on the power or something. A GoPro. Yeah.
That's right.
Your graph is gonna be like all distorted.
Big M is the midpoint, little m is slope. There's yet another way that we can actually prove that this is a right angle triangle.
Does knowing how to right angle triangle do anything?
No, but the question may be,
Oh, it's just.
is ABC a right angle triangle? So I kind of killed two birds with one stone.
Use the fact that this is a right angle triangle. You might never count.
Well, now can we get the area? Can we get the area of this triangle?
We can do anything.
Right? Now we need the length of AB, the length of BC, and we can get the area. Area of a triangle? Base times height divided by 2.
Really?
And because it's a right angle, there's another way that we could actually prove that this is a right angle triangle.
Do it the filter.
We have the side lengths. What do we know about the side lengths of a right angle triangle?
They're a squared plus b squared plus c
So
squared.
we use the Pythagorean theorem. Right, so I could do a squared plus b squared is equal to c squared. Question. Right? So if that proves true, then we have a right angle. I may not know which one right off, but at least I know it's a right angle triangle.
Then you gotta solve the triangle.
So which is the longest side? Well, looking at our values here, it has to be AC, which is 2 root 10. So this is root 40 squared. So my other two sides are really root 20 squared plus root 20 squared. Well, what's the square root of 20 squared? 20. 20. 20 plus 20, I got 40. Well, what's the square root of 40 squared?
40.
40. So the side lengths match a squared plus b squared equals c squared. So this is a right angle triangle. So which one would be the right angle then if we went this way? Because this was the longest side, opposite must be the right angle. Okay. So the question could have been, prove if triangle ABC is a right angle triangle or not, and if so, where's the right angle?
Real math is awesome.
Thank you. Wait till you get a little of this one. So here's a concept that you need to know and understand for this lesson. So the shortest distance from a point, so in this case the red dot, to a line. Shortest distance from a point to a line is the line segment that is perpendicular to the line from that point. So write that down first and then I'll demonstrate what those words actually mean. Sorry? Yeah, it's not a formula, but it's how we solve this. We need to understand this concept. So shortest distance from a point to a line is the line segment that is perpendicular to the line from that point. So what we mean by this is that if I drew a line from this point to this line, if I could get that line to intersect with that line at a 90-degree angle, this is the shortest distance to that line. Okay? So if I draw a line from this point to the line, if I make a cross at 90 degrees, that line is the shortest distance to that line. Well, or from the line to the point, yes. And you may wonder, well, who cares? Think of it as a practical example. This blue line, it might be a road, right? This red dot, could be a cottage sitting out in the woods. Okay?
Yeah.
And so normally you have to park your car over here, walk get to your cottage. Okay? So who knows where you might park your car? You might park it over here, park it over there. But eventually you want to build a road. I'm cheap. I want to build the shortest road possible. Because building roads are expensive. You gotta tear down trees, bulldoze, and all this stuff. So I want the shortest road from here to here. I want the shortest distance. So how can I calculate that? Therefore, I can calculate how much it will cost me to build my road and how hard my kids have to work to save that money. So we can build that road, right? So give them a goal, right? So this is one example of how you can actually apply this. Now, one thing I want to do is help you understand why is that the case. Why is that particular line, if it's a right angle, has to be the shortest distance? Let's assume it's not. Okay? Let's assume that that's not the shortest distance. Okay? There's another point on here, and I'll label it with a black point. There's another point on here that's actually shorter. So in other words, from here to here, this is shorter. That black line is shorter. But what happens when I draw that black line now? What do I get? What do you guys see? Triangle. Well, what kind of triangle do we have? A right angle triangle. Which one is the hypotenuse? The black line. But wait a minute. I just said the black line is shorter than the green line. But in a right angle triangle, the hypotenuse is what? The longest. Contradiction. So that's how you actually prove by contradiction. Assume one thing, go off and do something with it, and you prove a false concept. So if something turns out to be false, that means your initial assumption is false. So this is how I actually prove that that is the shortest distance. So let's make an example of this. And this was actually question 2 in that package that I said you guys couldn't do yet. This is that same question. Okay. So calculate the shortest distance between point A, which is 6, 5, and the line 2x minus y plus 3 is equal to 0. So, and that equate that line is given by the blue line here. So what? Let's finish writing first. So the diagram is there to help you visualize. Is not necessary for you to actually solve the problem. So what things do you think we need to solve this problem? What pieces of information do we need to solve the problem?
Turn the standard form equation into y equals m plus b.
Why?
Because then we have the slope of the line.
Okay. So one of the things that we're going to need is we need the slope of the line.
The slope of the existing line?
Slope of the existing line. Why do we need the slope of the existing line? What does that give us? Yeah, because remember that concept, right? If we draw that green line, we're going across here, this must be at a right angle. So this gives us negative reciprocal gives slope of perpendicular line, right? So that's what we want, that slope. What else do we need? Adrian? Yeah, I mean, if we're looking for this distance between this red dot to the blue line, we need a point on here, right? Or else how can we calculate that distance? So we need, what's special about this point? It's not a triangle.
Yeah. Yeah.
So we need the point of intersection between the two lines. Right? So we see that the green line green line and blue line, where they actually intersect, where they cross, is that second point that we need, right? So we're pretending that we're building a road. Eventually, it has to hit that road. It has to hit that existing road. So it's that point of intersection. So we need that point so we can calculate the length, right? Because we need 2 points to calculate the length. What's the third thing you think we need? Oh,
Another point on the line?
no, not quite.
Another line?
Yeah, well, we do have another line. Do we know the equation of it? No.
No.
That's what we need. So last thing we need is the equation of the perpendicular line. Okay, so in other words, we need the equation of that green line. Which one can we do? Which one can we do first?
Could we just take the point from the dot and the point that we chose and then do the length formula?
We don't know that point though. Well, we know the red point, but we don't know the green point. How do we know where that is? That's the main question up there. Where is that point on the blue line that we need to put that dot? We don't know. So this is what we're calculating for. That's what the first and the last thing do for us. Actually, all three things, that's what it does for us. It gives us that point. Okay, so we hear Daniel's question? His question is, well, why can't we just get this point so that we calculate the distance? Did I paraphrase correctly? We need these three things in order to get this point. Okay? You need all three of these things just to get that one point. And from there we can get the length. So which one can we do first? Slope of, yeah, well, we're given the equation of a line. Let's do one first. So we're given 2x minus y plus 3 is equal to 0. How can I get the slope of that line? Rearrange it how?
2 over 1.
Yeah, so we want to isolate for y. Or we want to get y by itself in this equation. Because then whatever the coefficient to x is our slope. So how can I isolate for y here? Can I? Multiply both sides by y? This is minus y. So how do we get, so we want to add y to both sides. So we get 2x minus y plus 3 plus y is equal to 0 plus y. You don't need to show this step, I just want to emphasize it. What are we really doing? Again, rid of the y on the left side. 2x plus 3 and 0 plus y just gives us y. So what's our slope then? Yeah, slope is just 2. So what's the slope that's perpendicular to it? Yeah, -1. So we flip the fraction. So this is 2 over 1.
Wait, 2 is the slope?
So 2 is the slope, right? This is y equals mx plus b form. Do you see that, Katie?
Yeah.
So 2 is our slope. But now we need the slope of that line going the other way, which is going to be perpendicular to it, 90 degrees. Yes.
And that's the slope of...
So this is the slope of the green line. So here, that's the slope, that's the perpendicular slope that we're looking for, right? So that's checkpoint number 1. We got the slope. What can we do next? The slope of the blue line is 2, but now we know the slope of the green line is going to be -0.5. And we want, that green line is important to us, right? That's the road that we want to build, or that's the line. So what else can we figure out now? Can we get to part of the intersection now?
We can get the equation.
Right, we can't get a point of intersection because we don't have two equations yet. Right, we don't have two equations of a line. But can we get the equation of perpendicular line now? So let's do that as number 2. Or actually it's 3 in the way we numbered it. So the second part. So what's the slope of that line again? And negative 1 over 2 x plus b. So how do I solve for b now?
You can sub in 6, 5.
Right? It's the only point that's given to us. But is this point on that line? I mean, that's the key question. Well, yeah, we're starting from there, so it has to be on that line. So when x is 6, y is 5. So we got 5. This is a minus a half. So equal to minus 3 plus b. Add 3 to both sides. So b is equal to 8. So therefore the equation of that second line is y is equal to negative 1/2 x plus 8. Keep in mind, this is one test question.
How much should this
How
be
many,
worth?
how long is this test gonna be?
Maybe 4.
For what?
Hours?
4 marks.
For like 10 minutes?
This is why you need to practice, because as you practice, how many formulas have you learned so far?
Too many.
Midpoint,
On it, took 2? Like,
length, length of a line.
I just learned base
Yeah, but then
times
you
length
need to
divided by 2.
memorize what you need to find.
This is where the practice comes in. The experience, what are we looking for? Right? And then you apply those formulas. This y equals mx plus b is not new to you. This is review from last year. Right? Yes, Adrian?
Wow.
After I finish this. So now that we got 2 things, can we get the third one now?
Yep.
Focus. How do we get that point of intersection? Right? So what method are you using there? And we have a second equation. Does this start to sound familiar? 2 equations. We want to find where x and y's are the same point of intersection. How do we do that? So what Trang said, meta term for that. Substitution. You guys remember that? Solving by substitution. So if y is equal to this, we want to sub y in for here. So here for 3, we want the point of intersection. 2x plus 3 is equal to negative 1/2 x plus 8. Right, so that's how we solve where those 2 lines cross.
Wait, where'd you get the 2x? Oh, it's part of the equation.
That was the first equation. I could use the original one,
Okay.
right? Plug y into that.
Wait, and then
So how do I solve for this?
Put x on one side.
So how do you get x on one side?
Subtract 2x.
You want to subtract 2x? 2x, subtract 2x from this side?
Well, yeah, and then do the other side.
So 2x plus 3 minus 2x equal to negative 1/2 x plus 8 minus 2x.
And then you put plus 8, and then you subtract.
So we subtract 8 from both sides, so we get 3 minus 8 is equal to what's negative 1/2 minus 2? Negative 5 over 2 x. So 3 minus 8 is just negative 5. So in order to isolate for x, the trick I use is I'm going to multiply by the reciprocal. So you multiply by negative 2 over 5 on both sides. Because by doing that, all those cancel out. I just get x over here, and here I just get left with x equals 2. Because negative 2 times negative 1 gives me positive 2. So x is equal to 2. Is that jogging the bell from the first unit?
Did you subtract the 2x, then you can put it with the negative 1/2 x?
Yeah, so that's what we did. Well, you could have done it another way. Yeah, you could add a half x on this side, add a half x on this side, subtract 3.
And you got negative 5 over 2x by just adding? Or
Well, here I get negative 5 over 2x by doing negative a half x minus 2x.
and to do that, you have to create common.
Yeah.
Okay.
So it would be negative a half minus 4 over 2,
Okay.
which gives us negative 5 over 2.
And then why do you have an 8? Oh, because you subtract.
Okay? So now that I have my x value, how do I get y? Yeah, we substitute x back into one of our equations. I'm going to do the first one. So we had 2x plus 3 is equal to y. Well, either 2. I don't want to work with fractions. I'd rather work with the integers. So that's why I chose the other one. So here I got 4 plus 3 is equal to y, so 7 is equal to y. So therefore this point is 2 comma 7. So finally, all that work just to answer Daniel's question of where was that point on the road, or that point on the line. Yes, Katie?
How come the negative 2 turned into a 2? Sorry. Like that.
Because when I cross reduce this was a negative 1, negative 2 times a negative 1, because this is a negative 5 here, right?
Oh, so it turned into a plus.
So yeah, so I cross reduce the 5, and then negative 2 times a negative 1.
So you flip the negative 5 over 2, sorry.
Yeah, multiply by the reciprocal.
Sure. And then you do the same thing to the other side.
Well, if I do one thing on one side, I have to do it to the other.
I guess they cancel each other out.
Okay? So yes, we need to be strong with the algebra. Need to be strong with arithmetic skills just to get that one freaking point. It is freaking. Like that Doritos commercial, right? You guys heard it on the radio? Freaking hot. It's freaking hot.
I heard that one.
I have to. I'd be lying if I said so.
So am I done?
Yeah.
Yeah.
No. What was the original question?
Wow, you serious?
I haven't calculated the distance yet.
Oh, I
But
have no room.
Oh, wait, we still
Man, will the test be like how
I think we should like just question the other side.
Well, so this test should be
Question?
short.
because if I multiply a fraction with its reciprocal, I'm always going to get 1. So if I have a fraction, a over b, if I multiply by b over a, I'm always going to get 1. Huh? Yeah, because I want in front of my x 1. Right? I want to isolate for x.
Can they maths? Alright, let's see how fast I can do it. 3, 2, 1.
Is that good? Is that high enough on you? Okay, so finally, the answer to the question.
When am I ever going to use this?
To calculate the length.
You can't just say that, Katie.
Yeah, I can. I know.
Nice.
You ever
Like maybe
if
I
you're
don't
caught
know.
in the way.
Like this can't be 4
But how
marks,
can
this
do
has
this?
to be 10 marks.
This is a lot of marks, I will grant you
Can you
that.
just make the whole thing one test?
Yeah, we
Well,
should
make a little
So all or nothing on this one question? I'm game for that. Easy for me to work.
Because then if you study for like, if you just make it that format.
Well, there's one thing we didn't cover. You didn't have, notice we didn't have to calculate any midpoints. So I
You
would
can just
throw.
put a little bonus question. Fun.
midpoints are easier than this.
Yeah,
Just do the midpoint.
This is a huge application question, and this is what, to me, this is the fun part
Is
of
this like
math of
8
solving.
marks?
probably closer to 8.
It's 4.47.
So let me finish this off.
Questions, we'll teach
X2 minus xy quantity squared plus y2 minus y1 quantity squared. So I got 2 minus 5, I think, was the original question.
2 minus 5, no.
What was the coordinates?
2 minus 6.
6 comma 5?
Yeah, 6 minus 5.
I said 24.
25. She said 25.
I'm at 24.
Oh, we got it.
7 times
So 2 minus 6, 7 minus 5. So that's the square root of negative 4 squared plus 2 squared. So we got 16 plus 4. And we get this answer of square root of 20.
4.4.
Which is equal to 2 root 5. I almost guarantee you now that there will be no question on the test where the answer is square root of 20.
Is that too easy?
So, yeah.
Because we've already done it 3 times.
I'm just gonna calculate.
To calculate what?
Sure.
So you need to calculate do minus 4 squared?
Yeah.
Is this the answer?
You can pick it up from Mr. Reynolds after school. So finally you got the answer to the length is square root of 20. Yes,
No,
Jay.
we don't have it in homework.
Leave it in radical form. You know what? If this was a word problem, you would want to convert, would actually want a decimal.
No.
So this could have been
Mr.
like,
Chan, you can't turn this into a word problem.
It takes a lot.
I sort of did.
There will-
There's a row with an equation of
No,
Mr.
no,
Brown
no, no,
has a
no.
cottage.
This
Why is it
road
gross?
totally messes me up.
Mr. Chan, you turn awesome. Like nothing.
Whoa, he's
Any questions on this?
You can't